Good morning, everybody. Today I'm going to discuss about EPS Unit 4 pointers and strings. First of all, we shall discuss what is a pointer. Pointer is a variable which contains the address of another variable. The syntax for a pointer is star variable name. So, as we know that every variable in the memory contains some address. A pointer contains is a special type of variable that contains the address of another variable. Like for example, here int star p. So p is a pointer to integer. That means p denotes a pointer that contains the address of an integer variable. Float star q. Here q is a variable that contains address of another variable of type float. Here q is a pointer variable which contains address of another normal variable which is of type float only. The data type of pointer and the normal variable should be of same type. Now we shall see an example. Here in this example program I have declared p as an pointer to integer, I as an integer variable. Here I am entering the value of I. Say that I have entered the value of I as 5. P is containing the address of I. Now I am printing the address. Since addresses are unsigned integers, so I want to use the type specifier as percentage %u. So here I am printing the address of I. I is stored at address 65,524. To get the value contained in address P, then we use an operator called as star P. This star P is also called as dereferencing of pointer. So when we use star P, we get the value which is stored at address 65,524, which is nothing but the value of I. Pointer to pointer. A single pointer contains the address of a normal variable. Pointer to pointer contains an address of another pointer. Here the syntax is data type star star variable name. Example int star star p. So p is a pointer to integer variable. That means p is a pointer to pointer that contains address of single pointer. That single pointer internally contains address of a normal variable. Float star star q denotes that q is a pointer that that contains address of single pointer of type float. The single pointer which internally contains address of normal variable of type float. Here I am explaining it as programming example. Here I have considered star p as a single pointer, star q as a double pointer, I as a normal variable. Here I am entering the value of I using scanner. Say that the value of I entered as 5. Now p is containing address of I. I is located in some memory location. I is having some address. That address is stored in P. Now I am printing the address of I. Here we can see that address of I is 65,522. P contains the address of I. Now value of I. Value of I is nothing but star P. Here I am accessing the value of I indirectly by using the star P. Star P is also known as dereferencing a pointer. P is containing 65,522. Now the value at 65,522 is 5. Now Q is equal to address of P. Here Q is a pointer to pointer. Q contains the address of a single pointer. Single pointer should contain address of a normal variable. Here I am printing address of P. Address of P. That is address of P is contained in Q. So when I print Q value, it is nothing but Q is containing the address of P. Next, I want to get the value of I using double pointer Q. So I need to apply 2 times dereferencing. If I print Q, it is nothing but the address of P. If I use star Q, it gives the address that is stored in single pointer p. If I again dereference, then I will get the value of I. Pointer arithmetic. We can perform arithmetic operations on the pointers like addition, subtraction, etc. Pointer arithmetic operations are increment, decrement, addition, subtraction. Increment pointer. If we increment a pointer by 1, the pointer will start pointing to immediately next location. This is somewhat different from the general arithmetic, since the value of the pointer will get increased by the size of the data type to which the pointer is pointing. Like for example, here I am considering P is of type integer pointer and I is of type integer variable. Now here I am entering the value of I. Value of I is 5. P contains address of I. Now I am printing address P as 65,524. Now if I increment the value of P, P is equal to P plus 1. Now I am again printing the address. Here we can see that earlier the address is 65,524. After P plus 1, we have got the address as 65,526. The difference is 2 because size of the integer type is 2 bytes. So that's why we will get the 2 bytes increment. Next, if we consider an example for float pointer. Float pointer is, here I is of type float, P is the pointer to float. Here I am entering the value of I. Say that the value of I is 5. Now P is containing address of I. Now I am printing the address 65,522. Now I am incrementing the value of P by 1. Now the address will be not 65,523 because size of the float type is 4 bytes. So next element or next address will be at 65,526. The second operation is decrementing pointer. Like increment, we can decrement a pointer variable. If we decrement a pointer where it will start pointing to the previous location. For example, here P is of type integer pointer, I is normal integer variable. Here I am entering the value of I. I am printing the address P, address 65,524. Now I am decrementing the pointer variable by 1. Now I am again printing the address P. Now the value printed is 65,522. Here we can see that the difference is 2 bytes because size of the integer is 2 bytes. Now if we consider an example for float pointer, P is pointer to float, I is of float variable. Now P contains address of I. So I am entering the value of I as 5. Here the value is not considered for time being. I want to show the difference of the addresses when decrement of pointer takes place. Here I am printing the address as 65,522. When I decrement by 1, then address is 4 bytes difference. It refers to the previous location because size of the float is 4 bytes. Pointer addition. We can add a value to a pointer. As we have added incremented by 1, similarly we can add any integer value to a pointer. For example, here I consider P as a pointer to integer variable, I is of integer variable. Now enter the value of I. Here I am entering the value 5, but 5 I am not using in this program. Just for time, for the program sake, I am entering the value of I. Now P is containing address of I. Now I am printing initially what is the address of I. Address of I is nothing but 65,524. Now when I increment by I value, what is the value of I? I is 5. So what is P? P is 65,524 plus 5. It will be not equal to 65,529. It will be equal to 65,524 plus 10. Why 10? Because 5 elements of type integer. Integer size is 2 bytes. So 5 into 2 is 10. So 65,524 plus 10 is equal to 65,534. Similarly, the next operation is pointer subtraction. We can subtract a value to the pointer variable. Subtracting any number from a pointer variable will give an address. Now, here I have taken P is of type integer pointer. I is the normal integer variable. Here I am entering the value of I as 5. So initially P is containing address of 5. Say that address of I is 65,524. Now I am displaying that address onto the screen. Now I am subtracting P is equal to P minus I. So what is the value of P? P is 65,524. What is the value of I? I is 5. So 65,524 minus 5 is not equal to 65,519. It is equal to 65,514 because 5 elements. You should consider these 5 elements. Each element is of type integer. Integer size is 2 bytes. So 5 into 2, it is 10. So 65,524 minus 10 is equal to, we get the address as 65,514. We can also subtract an address from another address. This will result in a number. For example, P is of integer pointer, Q is of integer pointer, I is normal variable. Result is used for storing the subtraction of two pointers. Like for example, here enter the value of I. Here I am entering value address of value for I. I have entered the value for I as 5. Now P is containing address of I, Q is containing address of I. Initially both are pointing to same memory location. Now I am printing Q. So what is the Q address? 65,524. That is, it is nothing but address of I. Now I am incrementing the value of pointer P. P is equal to P plus 3. P is equal to P plus 3. So now, if this is Q is 65,524 plus 3 means we will get the result as 65,530. 65,530. Now I want to subtract P minus Q. 65,530 minus 65,524. It is not equal to 6 because the difference might be an integer value 6, but the number of elements between these two addresses is 3 elements. Each element is of type integer. So that's why we are getting 3. 65,530 minus 65,524 is equal to 3, not 6. Because each the elements between these two addresses is 3 elements of type integer. Pointers to arrays. As we already know, array names are converted to pointers. That means if we give the name of the array, that is converted as a starting address of the array. That is the reason why you can use pointers to access the elements of the array. For example, here I am considering array of 10 integer elements. P is pointer, I is normal integer variable, n and some are also normal integer variable. Now I am entering the value of n. Here suppose that n is 5. Now I am entering the value for an array. I am entering 5 values which are stored in array A. Now sum is equal to 0. In this program I want to find the sum of the array elements using pointers. P is equal to A. As here we see that array names are converted to pointers. So when I say just A indicates the starting address of the array. That starting address of the array is stored in P. Now here I'm displaying P and A address. Here we can see that both are same. That means if I refer an array by name, then it displays the starting address of the array. Here P is containing the starting address of the array, so P also points to array. That is, P is containing 65,502. Now here I am finding the sum of array elements. The actual array elements are stored in array A. Now I am accessing the array elements by using pointer. So P, what is P is containing? P is containing the starting address of the array. Now when I apply P plus I, what is the value of I? I is 0. So 65,502 plus 0 is 65,502. When I apply dereferencing operator star, then I will get the value 1. Now what is the sum contains? Sum contains value 1. I plus plus. Value of I is 1. P plus 1. 65,502 plus 1 is nothing but 65,504 because the size of the integer is 2 bytes. So when I apply dereferencing operator, we get the value which is present in the next location, which is 2. So 1 plus 2 is 3. Again I plus plus. Value of I is 2. 2 is less than 5. Now P plus I. What is P? 65,502 plus 2. 65,506 we'll get because plus 2 is nothing but since size of integer is 2 bytes plus 2, 2 into 2 that is 65,502 plus 4. It is nothing but 65,506 which is we get element 3. So earlier sum is containing 3. 3 plus 3 is 6. Now the new value of sum is 6. I plus plus. Value of I is 3. 3 is less than 5. Again, in the same way, we will add the remaining elements. Finally, I am displaying the sum value. In this, I want to you people to know that whenever we write a name of the array, it is nothing but the starting address. So array is also called as a constant pointer. Whenever I name A is an address. The address of the array cannot be moved. Array address is fixed address. So here I am storing the values in array A and I am accessing by using the pointer. So pointers and arrays are related. Passing an array to a function. Just now I have described that the name of the array contains the first element of the array element. Whenever we mention the array name, contains the address of the first element. Here we must notice that we need to pass only the name of the array in the function, which is intended to accept the array. The array defined as a formal parameter will automatically refer to the array specified by the array name defined in the actual parameter. So, passing an array to a function. What does this mean? Whenever we want to pass more than one element, array. What is an array? An array is a collection of elements. So whenever we want to pass an array, collection of elements to a function, then the array name is passed. Only the array name of the array, and the number of elements. The meaning of this above statement I am describing by using a program. Here, this program contains two functions. One is func, another is main function. As we know that whenever the program is executed, always the main function is executed first. Now, here we are discussing the topic about passing an array to a function. So here, what is the array is containing? Array is containing 5 elements. I initialize with 1, 2, 3, 4, 5. Now, whenever I am calling the array, whenever I am calling the function, here I am passing the array name and the number of elements. Now the control is transferred here. Now what does P contains? P contains address of P is nothing but it is reference to A. N is containing value 5. That means here the name of the array function. The array is defined as a formal parameter. We automatically refer to the array specified by the array name defined in the as an actual parameter. This is the actual parameter. This is the formal parameter. P is referring to A. So whatever the changes we do here, that will be also reflected in in this function also, in this array. So P acts as a pointer in this function. So I am accessing the elements of the array by using P. P I am accessing as P of I. P of I. Here I want to find the sum of the elements of the array. So sum of the elements of the array is 15. So here I am passing the element array name. Here I am. So this P is referring to this. This is the actual parameter. This is the formal parameter. Next program, I want to show that whatever the changes are done inside this function are reflected back in this function. That is nothing but call by reference. So here I want to show that here the array is containing the elements, 5 elements, 1, 2, 3, 4, 5. I is the normal variable. When I am calling the function, I am passing only the array name with the number of elements. So when the function is called, control is transferred here. Here P is referring to A. P is pointing to A. Now I am accessing the values of array. Values of array. I am changing the values of array by 10. So after the function completes its execution, control comes back to main function. Here I am displaying the values of array A. So what are the initial values of array A? 1, 2, 3, 4, 5. Now after this function call, each element is incremented by 10. That's why we get the output as 11, 12, 13, 14, and 15. So here P is the formal parameter, A is the actual parameter. P is pointing to A. P is indirectly converted into pointer. Memory allocation functions. The concept of dynamic memory allocation in C language enables the programmer to allocate the memory at runtime. Dynamic memory allocation in C language is possible by using four functions of std lib.h header file. Now, the four functions are malloc, calloc, realloc, and free functions. These functions are present in standard library.h. So what is this dynamic memory allocation? The memory allocated during runtime is called as dynamic memory allocation. So before we are going to dynamic memory allocation, first we need to know what is static memory allocation. Static memory allocation is the memory is allocated during compile time. So in Turbo C, we are using Alt C for compiling, Alt R is for running the program. So memory allocated during compile time is known as static memory allocation. Memory allocated during runtime is known as dynamic memory allocation. That is done by using these four functions, malloc, calloc, realloc, and free function, which are present in standard library.h. Memory can't be increased while executing the program. So here static means it is fixed memory. Fixed memory used in array. Like if I declare int a of 10, a of 10 cannot be expanded to a of 20 during runtime. It is fixed. We have to work with only 10 elements. We cannot work with 20 elements, more than 10 elements. Here, dynamic memory allocation. Memory can be increased while executing the program. When you are running the program, Alt R, when you Alt R in Turbo C, when you are running the program, that time you can increase or decrease the memory depending on the requirement of the program. This is used in case of array, static memory allocation. Dynamic memory allocation is used in case of linked list. Linked list is a concept which is used in data structure. We are going to see in the next semester. So four functions are there: malloc, calloc, realloc, and free function. So the malloc function allocates single block of requested memory. It does not initialize memory at execution time. So it has garbage values initially. It returns null if memory is not sufficient. That means by using malloc function, we can allocate some memory in the heap. Primary memory is divided into different segments. I have shared previous videos. You can watch that videos about regarding the primary memory segments. So here initial values are not assigned any value. So initial values, it will contain garbage. If there is not enough memory, like for example, if I want to allocate for 1000 elements of data, integer elements, if the memory is not sufficient, not available, then the malloc function will return null, indicating that memory is not available in the heap memory area. Now, the syntax for this malloc function is malloc, how many bytes you want to allocate in the heap memory area, that we need to typecast it. Like for example, if I want to work with integer element, then I have to typecast with int star. If I want to allocate work with float element, then I have to typecast with float star. If I want to work with double element, then I have to typecast with double star. So malloc will return a general pointer. The general pointer is known as void star. That void star should be typecasted to the specific pointer type which we want to work with. Int star, it is typecasted with int star if we want to work with integer. It is typecasted with float star if you want to work with float elements. So PTR, here PTR is a pointer variable which contains the starting address of the allocated memory. So in this program, I want to show that the memory is allocated by using malloc function dynamically at runtime, memory allocated using malloc. So here I am considering n, the number of elements, I for traversing, p is the pointer to integer variable. So enter the value for n. How many elements you want to allocate in the memory? So here I want to allocate n elements, n. So what type of elements I want to store? I want to store integer type. So n into size of integer. What is the size of integer in Turbo C? It is 2 bytes. So n, suppose I have entered n value as 5. 5 into 2 is 10. So totally 10 bytes is allocated. 10 bytes is allocated in the heap memory. In the heap memory. Now, since malloc function will return a generic pointer void star, now I want to work with integer values. Integer values because pointer is of type integer. Then I need to typecast with int star. Now P contains the starting address of the allocated memory in heap. Now if this function returns null, that means 5 into 2 bytes, 5 into 2. If 10 bytes is not available in the heap memory, then malloc function will return null. Then I am printing a message, sorry, unable to allocate memory, return. Return means complete the, come outside of the program execution. If P is containing the valid address, then P contains the starting address of the allocated memory. Now I'm entering the values of the array. Here I'm entering the values of the array by using the pointer. P contains the address of the array plus I. So P plus I is 0. So it will be starting address only. So since scanf needs address, so P is the address because P is of pointer type. So whatever the value we enter, it is stored at the P address. So next I plus plus. I value is incremented by 1. So whatever the value next element we are entering, it is stored at p plus I. So next integer location. Similarly, 5 elements are allocated in the heap memory. Now, here I want to display the values which I have entered in the heap memory by using star of p plus I. As we already know that star indicates dereferencing. That means we get the value which is at this address p plus 0 p. Star p means we get the value 1. I plus plus I is 1. P plus 1 means next integer location. Next integer location, if I apply star dereferencing operator, I will get the value 2. Similarly, all the values are printed which are stored in the memory, heap memory by using malloc function. The next memory allocation function is calloc. The calloc function allocates multiple blocks of requested memory. It initializes all the bytes to 0. It returns null if memory is not sufficient. In malloc function, it will contain by default the values as garbage values. In calloc, it will initialize the memory with 0. As in case of malloc, if the memory is not sufficient, the malloc function will return null. Similarly, in calloc also, if the memory is not available, then the calloc function returns null pointer. So the syntax for calloc function is calloc, the number of elements and size of the elements. And you are typecasting with the pointer type. Here pointer type is of integer type means you need to typecast with int star. If the pointer type is of Float pointer means you need to typecast with float star because scala function will return a generic pointer void star. Here we are seeing an example program by using calloc. So here I am taking p is of integer pointer, n and I are normal integer variables. That means I want to work with integer values. P is a pointer to integer. So here I am entering the value of n. I am allocating the value by using calloc. I am typecasting with integer because P is of type integer pointer. Memory allocated using calloc. P is equal to null. This is not malloc, this is calloc. If P is null, that means if the memory is not available, then the calloc function will return null. Sorry, unable to allocate the memory. Return means terminate the program execution. If P contains, if calloc returns a valid memory address, that means that the memory is available in heap. Then I'm entering the values of the array. As we have seen by using malloc, same program I have written, I'm entering the values, but here I'm displaying the values. But only the difference between malloc and calloc is in calloc, the values initially they are assigned as 0 by default. Realloc function. If the memory is not sufficient for malloc or calloc, you can reallocate the memory by using realloc function. In short, it changes the memory size. That means initially we have allocated some memory. During runtime, if you want to extend the memory or if you want to reduce the memory which is already allocated by malloc or calloc function, that can be done by using the realloc function. First, the memory should be allocated by using malloc or calloc function. By using realloc function, we can extend the existing memory with the new size. The new size can be a bigger size or the smaller size. If the memory size is increased, then the previous values of the memory which is earlier allocated by using malloc or calloc are copied into the new location. If there is no memory at the same place which is already allocated by using malloc or calloc. If the new size is less than the malloc or calloc size allocated memory, then also the previous values are restored by using the realloc function. Finally, free function. The memory occupied by using malloc or calloc function must be released by calling the free function. Otherwise, it will consume memory until the program exits. This is the syntax for free. It will take one variable, pointer variable, free of pointer. That means during the runtime, you have allocated memory by using malloc or calloc. During the runtime itself, you want to free the memory so that that memory can be utilized by the other programs. Then you can use this function free of pointer variable. The memory is deallocated during runtime. If you don't use this free function, then the memory will be retained until the complete program execution completes. Thank you.